Good morning, students. Once again, we will study here the parallel combination of resistance. Previous day, we have seen the combination of resistance. There are two types of combination. So, on previous day, we have seen the series combination. Today, we'll see the parallel combination of resistance. This is the same topic of the same chapter, current electricity. So what is parallel combination of resistance? So it is when two or more than two resistance. Two or more than two resistance connected between two fixed point is known as parallel combination of resistance. So here we are taking here A and B are two fixed point, and between these two fixed point, three resistance. We are taking here three resistance. It is R1, R2, and R3. So three resistance connected between two fixed points. Here A and B is the fixed point. So according to the definition of the parallel combination of resistance, when two or more than two resistance connected between two fixed points is known as a parallel combination of resistance. So here the circuit diagram of parallel combination of resistance. It is a ammeter, as you know, as already explained in a previous class. Ammeter, which is connected always in series combination of the resistance. Voltmeter, it is always connected to parallel of the resistance. And this is the rheostat, switch, and the sources of direct current battery. So these are the arrangement of the apparatus. Where ammeter is an instrument in which we measure the how much current flow through this circuit. V is the instrument in which we see how much potential difference between these two terminals. We can connect between here and here, or we can connect it these 2 points, where we will connect this voltmeter between 2 points, or we can connect either this side or this side. Rheostat is an apparatus, and its work is control the current flow through this circuit. Switch. This dot shows the circuit is closed. There are two types of circuit: open circuit and closed circuit. As we will remove this dot, it means circuit is open circuit. This circuit is open circuit. Means current doesn't flow through this circuit completely. But as we put dot here, this dot indicates the circuit is complete and current flow through this circuit. This is the sources of current battery. This is positive terminals and negative terminals. And we will connect the positive terminal of ammeter to the positive terminal of battery. Negative terminal of ammeter to the positive terminal of battery, and negative terminal of voltmeter is negative terminal of the batteries. Now here we will find out the equivalent resistance. So what is the value of the equivalent resistance when three resistance combine in parallel combinations? Our household wiring, our household electric wiring is always in parallel combinations. We will see later on the advantages of the parallel combination. Now we will explain the expressions for the parallel combination. Now, what is according to the Ohm's law? We know that according to Ohm's law, we know that V equal to IR. Look at here. There are three resistance and all three resistances takes whatever the capacity of the resistance, the current supplied through the resistance according to the capacity. So all the resistance have a different value. So the value of the current from each resistance is different. So here according to the Ohm's law, V equal to IR. Potential difference remains same for the entire circuit, for the all three resistance, but the value of current is different according to the power of the resistance or according to the strength of the resistance. So here V equal to I1 for the first resistance I1 and resistance is R1. This is equation 1. Now again potential difference V equal to I2 R2 means the I2 is the current for the R2 resistance and V equal to I3 R3 because the potential difference for all the resistance are equal. 2 and 3. But here we have to find out the value of the current, how much current flow through each resistance. Now from first equation we will find out how much current flow through the resistance R1. Then from 1, I1 is the current, I1 equal to V upon R1. Similarly, I2 equal to V upon R2 and I3 equal to V upon R3. Because we have to find out the value of the current for entire circuit, and separately how much current consumed by each resistance. So R1 resistance consumed current V upon R1, R2 resistance V upon R2 and R3 resistance V upon R3. Now what is the value of total current for this circuit? So the value of total current is I. Now when we add these three, now we will add or the total current. What is the total current flow through the circuit? The total current is I. Then I equal to, we can write I1 plus I2 plus I3, because I1, I2 and I3 are the current for the resistance R1 and R1, R2 and R3 respectively. Now we will put the value of I1. The value of I1 is V upon R1. Value of I2 is V upon R2 and I3 is V upon R3. It is I. But according to Ohm's law, we know that I equal to V upon R. So here we can write in place of I, V upon R, and in this side, right hand side, potential difference means V is common for all the resistance, because the resistance are connected between 2 points. So the potential difference will remain same. So here V is common, then it's 1 upon R1 plus 1 upon R2 plus 1 upon R3. So here V is cancelled. So we can write 1 upon Rp. Rp means resistance, equivalent resistance in parallel. So 1 upon equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the required expression for the resistance when the resistance connected in parallel. Suppose that if n resistance connected in parallel, then what is the equivalent resistance for that circuit? So we can write here 1 upon Rp. Here we can write first if n resistance connected in parallel, then what is the equivalent resistance? It will be 1 upon Rp equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus plus 1 upon Rn. So this is the equivalent resistance for n resistance when connected in parallel. Now we'll see the advantages of parallel combination and series combination. Advantage of parallel combination and series combination. What is the advantage? So first here we'll see the advantages. Advantage of series combination. Advantage of series combination. In this combination, we can operate several appliances from one switch. It can operate several appliances from one switch. And advantage of parallel combination. In parallel combination, we can operate only those appliances which we need. It means our household wiring is a parallel combination. So if you want to operate the fan, we can only operate fan. If you want operate bulb, we can only operate bulb. If you want to operate TV, freeze, any kinds of appliances, so we can operate only that kinds of appliances. But in series combination, if you want to operate bulb, it can operate fan, TV, freeze, all the electrical appliances. So this is the harmful for the wire through which all they connected, because in series combination resistance gradually increase because all the appliances connected in one wire. So these are the advantages and disadvantages of the combination series and parallel. Now we'll see here the effects of current. As I told before, the effects of current, you will see some numericals which is based on series combination and parallel combination. Here I am giving one numerical which is based on series combination. If three resistance, which value is 3 ohm, 5 ohm and 6 ohm, connected in series. So what is the equivalent resistance? So the equivalent resistance R equal to, we'll add all three. So 3 ohm plus 5 ohm plus 6 ohm. It's become 14 ohm. This is the equivalent resistance when these three resistance connect in series. Suppose that these three resistance connect in series with 12 volt battery. So what is the current? Find the current. Find current. How much current flow through this circuit? So first we will find out the equivalent resistance, which is 14 ohm. Now here we will use the Ohm's law. And what is Ohm's law? Ohm's law is V equal to IR. We have to find out here I. Means I is the symbol of current. So I equal to B upon R. So we will put all these values. B means potential difference. It is 12 volt. And R is equivalent resistance for the circuit. It is 14. It's become 6 upon 7. 6 upon 7 ampere, because ampere is the unit of the current. So if three resistance, which value is 3 ohm, 5 ohm and 6 ohm, connected in series with 12 volt battery, so the current flow through the circuit is 6 upon 7 ohm. Now the same question, but the resistance connect in parallel. Second question. Then what happens? Same question, same value of the resistance, same potential difference. Then we have to find out how much current flow through this circuit. So first here we'll find out the value of equivalent resistance. And equivalent resistance is 1 upon R equal to here 1 upon 3 plus 1 upon 5 plus 1 upon 6. You take LCM, which is 30, 10, 6, 5, 21 upon 30. This is 1 upon R. Now R equal to 30 upon 21. 10 upon 7. 10 upon 7, it is 4. So value of resistance when these three resistance connect in series. So here we can see the advantages of the parallel combination. In series combination, the value of total resistance was 14 ohm. But the same appliances connected in parallel, the value becomes 10 by 7, which is very less in comparison to the series combination. Now we have resistance, we have potential difference. Can we find out the value of current, how much current flow through this circuit? Yes. Now here we will apply again the Ohm's law. According to Ohm's law, V equal to IR and I equal to V upon R. We will put all this value. B means potential difference, which value is 12, and resistance, which value is 10 upon 7. So 10, this is 7, and the unit of current is ampere. 5, 4. So it's become 28 by 5 ampere, means 5.6 ampere. So the same appliances connected in parallel and series, but the value of current is different for both the condition. Now we will see the other topic, which is effects of current. As you know that we have been already discussed earlier that effects of current. There are three effects of current. Effects of current. There are three effects of current. First is heating effect of current. First is heating effect of current. Second is magnetic effect of current. And third one is chemical effect of current. So there are three effects of current. So in this chapter, current electricity, we will study heating effect of current. The next chapter is magnetic effect of, this is separate chapter. And chemical effect, this topic you will study in your higher classes, in class 12. But I will explain later on about chemical effects of current. So here we will study heating effect of current. Now what is heating effect of current? When the electricity flow through the circuit, due to the flow of electron, because we know that the conductor, which is made up of three subatomic particles, and electron present in free state. You must remember it that electricity